So in this video, we are going to build a full Node.js application that handles audio files. We have two main goals. First, we will try to connect to Hugging Face to build a speech-to-AI pipeline using Whisper for transcription and a text-to-speech library to regenerate the audio. Second, we'll see how to build a real noise reducer that cleans up background static while keeping your actual voice. We're using Node.js, Express, TypeScript, and Multer for handling the files. This video is going to be completely raw and without any pre-planning. I'll face real errors and code issues as we build it out, and we'll fix them on the fly. I mostly use AI tools to generate the code and troubleshoot compilation issues, so you'll see exactly how that vibe coding process works in real time. Let us get into the project setup and start coding.
First, we need to ask AI about folder structure and architecture. We want to keep our TypeScript project clean from the start, so we will let the model generate the standard SRC folders, routes, and services setup. This saves us time and gives us a solid base before we write any Express logic. Now, let us initialize the project. We will run npm init to create our package.json file, and then install TypeScript, TypeScript types, and nodemon, so our server restarts automatically when we make changes. We also need to configure our tsconfig.json file to support modern ES6 module imports. Since we want to use the latest JavaScript syntax for imports and exports throughout this service, let's set up the basic environment so we can start writing our server code. Now we will create our folders and files. Inside the SRC directory, we need to add separate folders for routes, controllers, and services to keep the backend organized. We also need an uploads directory at the root level to store the files we send through Postman. And we will create our main app.ts entry point to test that the nodemon compiler is running cleanly. Now we will add the core logic inside our app.ts file. We need to import Express, parse incoming JSON payloads, and read our server port directly from an environment file, which we will set as 1500. Let us write a quick health check endpoint that returns a simple success message. Start the local server via nodemon, and then jump over to Postman to fire a request and make sure everything boots up successfully. Now we need to create a task.ts file inside our types directory to define how our audio jobs will look, like tracking the ID, status, and file URLs. After that, we will create a dummy AI service file that just returns fake task data for now. This lets us wire up our basic state management and memory map before we try adding the real audio processing logic later on. Now we need to figure out how to implement the actual audio cleaning logic. We could look into third-party APIs like Clean Voice or other paid tools, but we want to try using Hugging Face since it gives us access to open-source models for free. Let us go with Hugging Face and see how we can connect our code to their serverless routing endpoints using our access token. Now we will create our controller and routes files to handle the incoming API requests. We need to wire up the router to take audio file uploads and pass them down to our service layer. After importing these new routes into our main app.ts file, we will probably see some TypeScript compilation errors with module paths and types. So we will use AI to fix those imports and get the compiler back to green. So all the TS-related issues are fixed now. Let's test it into Postman. We need 2 endpoints to make this workflow work properly. First, we will create a post trigger request that lets us upload the audio file and starts our background process. And second, we will make a GET request using the task ID, so we can check the current state and see if it is still processing, completed, or failed. Now that our endpoints are working properly, let us install the Hugging Face Inference package. We will update our AI service file to use the official SDK and pass our authorization token from the environment file. We will likely hit some TypeScript issues regarding how the binary file buffer is typed when sending it to the model. So we will look at the errors and fix them to make sure the data streams properly. So the issues are fixed now. Let me show you how you can get access token from Hugging Face. You need to go and sign up on this website, huggingface.co, and then go to your settings page. From there, click on Access Tokens. Then hit Create New Token. You need to choose Read as the token type and give it any name you want. Finally, click the Create Token button, copy that key, and paste it directly into your envir file under your token variable. Let's restart the server. Inside our AI service code, we made changes, like setting up our absolute file paths and initializing the Hugging Face client using our environment variable. We have our public method for creating the task container immediately, and a private method that processes the audio file in the background, so the user does not have to wait. We will try using the speech brain model from Hugging Face to handle our track, so everything looks good for now. Now, let us test with Postman. First, we will send our audio processing request and then pull the status endpoint to see what happens. It looks like the server crashed. We ran into model specification issues because the Hugging Face client could not resolve the specific model path we gave it.
To simplify things, we will change our approach from using the official SDK to hitting the Hugging Face Inference APIs directly using standard fetch requests. Our first API URL was slightly incorrect, so we had to look at the official documentation to grab the right endpoint structure.
Once the API call went through, we realized the Hugging Face endpoint does not directly handle audio formats like M4A very well. To get around this, we are going to change our approach entirely and turn this into a transcription and resynthesis pipeline. We will send the audio to OpenAI's Whisper model on Hugging Face to get the raw text, and then we will use the gTTS package locally to convert that text back into clean speech.
When we updated our AI service to do this, we started hitting streaming issues and type errors regarding how our file buffers were read. We modified our code to support different file extensions, and the process finally started running in the background. However, after about 3 minutes of waiting, the Hugging Face Cloud API timed out on us because sending raw, uncompressed audio data took too long, and the model was struggling to parse the format.
To fix the timeout and format issues, we need to convert everything to a strict 16 kHz mono WAV format before sending it to the model. That means we need to install Fluent FFmpeg to handle the conversion. When we ran it, Fluent FFmpeg could not find the native binaries on the machine, so we also need to install FFmpeg static and FFprobe static to bundle the paths directly into our Node project.
After setting up the paths, we hit one last error, where the audio data was being read as a raw uint 8-byte array, but the transformers framework strictly demanded a float 32 array for its mathematical calculations. We wrote a quick buffer casting function to map the memory blocks correctly.
Now that all the fixes are in place, our pipeline finally ran through to completion without any cloud timeouts. Let us download the output asset from our uploads folder and see exactly how it sounds.
First one is the raw recording with all the original background noise.
Hello, this is a sample voice recording.
And the second one is our final speech-to-AI speech-converted recording.
Hello, this is a symbol of Visagodig.
So it's working, but it's still making mistakes with the words. You can easily fix this by changing the AI model for better speech recognition.
Now, let's just turn it into a real noise reducer, which gives you the same speech but with reduced noise. For that, we need to remove the AI-related processes from our code and implement digital signal processing directly on our server using fluent FFmpeg audio filters. We will build an internal filter chain using the fast Fourier transform denoise algorithm combined with high-pass and low-pass filters to target and strip out specific background room hums and microphone hertz frequencies. This means our Node server will process and clean your actual voice performance entirely locally without sending any data to the cloud or hitting external API limits. Let us rewrite the backend service method and run our final test through Postman.
So it worked correctly. Now let's just hear the final audio with the reduced noise to see how clean the track sounds.
Hello, this is a sample voice recording.
So it sounded really good and actually reduced the noise. Our local filter chain managed to cut out the steady background hiss and room static completely while keeping my voice sounding completely natural. This proves you do not always need a heavy cloud AI model to handle simple audio cleanup tasks, when a few lines of native code can do the job instantly for free. So I will put the link of the code in description and let me know what you think in the comments below. Also, check out my channel for more AI and coding related content. See you in the next video.